In today's lesson, we're going to look at graphing radicals. Radicals are functions that are either square roots or cube roots or other types of roots. Today we're specifically looking at square roots and cube roots, and we will see some similarities in how to graph these with some of the other things that we've learned how to graph as far as shifting the graphs around, stretching them, and flipping them over. First, we're going to take a look at our basic square root graphs. So our function is the square root of x. It is going to be a parabola opening sideways, but it's only half of the parabola. So whenever we take a look at this function, we'll start at the origin. It has not been shifted around. We'll take a look at one that has been shifted in a little bit. We're going to go over 1 and up 1, and we're only going to graph a parabola that's opening sideways, but we're only going to graph the top half of this parabola. So this is basically what our square root graph looks like. It goes on indefinitely toward the right, but it has a very definite starting point at the origin. For our next function, we're going to take a look at the square root of x plus 1 minus 2. So we're going to take the square root graph that we had before and we're going to move it around. So since our plus 1 is inside the house, inside the function, it's going to move the opposite direction of what you would think. So instead of right 1, it's actually going to move to the left 1. And the minus 2 being outside of the house can jump up and down as high as it wants, but it's going to go in the direction that you know that it goes, which is down 2. So instead of starting at the origin, the shift is going to take it left 1 and down 2. So this is the dot that we're going to start from. That's our beginning dot, or our anchor dot. And it's not stretched at all. We'll take a look in a little bit about one being stretched. It's not stretched. So we're going to go over 1, up 1. And we're going to graph this parabola, but the parabola is opening sideways, not up. So our sideways parabola is going to look like this. And again, we're just draw the top half of this parabola. If we were to try to draw the bottom half as well, what we'll notice is that it would no longer be a function because it would fail the vertical line test. On this problem, it hasn't been shifted. We're not adding or subtracting things inside or outside. So my beginning point, my anchor point, is still at the origin. So we still have this dot at the origin. It's been stretched by a factor of 2. So this is the value of a that we've looked at before whenever we've looked at parabolas and quadratics and some other graphs where we stretch things. So what I would actually do is I would go over 1 and up a, except that in this case I have a negative symbol there. So instead of going over 1 and up a, I'll go over 1 and down a. So I'm going to go over 1 and down 2. So over 1, down 2. I have a parabola opening sideways and it starts from here. So this is actually going to produce for us the bottom half of a parabola. So again, whenever we have a multiplier in front, that's going to be a stretch by going over 1 and up a. In this case we had a negative 2, which means we're actually going over 1 and down 2. And again, this is just half of the parabola, and in this case it ends up being the bottom half. Our next problem involves a negative on the inside. And if you remember, an inside is always a left and right motion. So this is a reflection in the left-right direction. So instead of counting toward the right, I'm actually going to have to count toward the left, and my half of my parabola is going to open toward the left instead of toward the right. The other thing that this square root function is doing is it is moved up 1. So my anchor point is beginning up 1 at 0, 1. And what we said is it's going to be reflected toward the left-right direction. So instead of going over 1, up 1, I'm actually going to go left 1, up 1. So my square root function is actually opening toward the left. And that's because this negative sign inside the parentheses as a multiplier flips it in the left-right direction. So instead of it opening toward the right, it's actually going to open toward the left. So those are the types of square root functions that we look at. Our cube root function is going to have very similar characteristics. Some of the things to keep in mind as we're going through our cube root function is we're going to be looking at shifting the point, just like we did in the square root graphs. We're also going to use our a value, and we'll go right 1 and up a. Additionally though, and this is what's different about the cube root function, is that we're going to create another part of the graph by going left 1 and down a. We're going to have curves that go to the right as well as curves that go to the left. So whenever we look at this function, we can look at a basic cube root graph. And the basic cube root graph that we have is going to start at the origin, just like we did before. We'll go over 1 and up 1. So this looks just like the square root graph that we had before. So if it were just a square root graph, we would have this piece. Okay. The cube root graph says also go left 1 and down 1. And the shape that we create is basically an S-type shape. So as we go from our anchor point, our center point here, toward the right, it's going to look like a parabola opening to the right. It's half that parabola opening toward the right. And as we come back toward our left, it's going to be the bottom part of the parabola opening toward the left. So we get this S shape here. So for our cube root function here, it's a cube root because we have this 3 as the index here. And this cube root graph is going to be shifted. Inside the function it has -2, so we're going to shift it to the right 2 units. Outside the function it has a +3, so we're going to shift it up 3 units. So my anchor point, my beginning point, is going to go 2 to the right and up 3. This is the point that we're going to base things off of. From here, I'm going to go over 1 and up a. And again, a is a multiplier in front, and I don't have a multiplier in front, so that is an understood 1. So we'll go 1 to the right and up 1. That's going to create a parabola opening sideways. The half parabola opening sideways looks like this. And we'll step 1 to the left and down 1 to create another dot here. This part is going to be half of a parabola opening toward the left. So our shape ends up like this. Again, it's this S shape. It does open toward the right and it does open toward the left in both directions. Here we have a cube root function, and it is multiplied by -2. So it's not shifted any, so our beginning dot, our anchor point, is at the origin. And if this were just a 2, then I would say go over 1 and up 2, to the right 1 and up 2, to the left 1 and down 2, and then we would create our parabolas, half parabolas opening toward the sides. It actually says -2, so when I go to the right 1, I'm actually going to go down 2. I'm going to go the opposite direction I normally would have there. And when we go to the left 1, we'll go up 2. And again, this kind of gets tricky. I don't want my half parabola pieces to be opening up. I want it opening left. So this left part right here is actually going to open toward the left this way. In this direction, I actually want it to open toward the right, not down, but toward the right. So as I come down, I'm going to curve it so that way it opens toward the right. So that is our cube root function, and it has a -2 as a coefficient, which is stretching it in the y direction by a factor of 2, but it's been flipped over from what the basic cube root graph looks like. There is a subtle distinction between what a cube root graph looks like and a square root graph looks like. One of the subtle pieces is how quickly this curves. For our purposes, we're going to say that a square root graph has one piece on the graph and a cube root graph has two pieces on the graph. So as long as we're curving in the correct direction, that's the part that we're interested in.